Okay, so angle properties in polygons. We are on page 18 in your booklet. So, consider the following. A pentagon has 3 right angles. And all sides except the bottom side are equal length. How could you find the sum of the interior angles of a pentagon? What is the sum of the interior angles of a pentagon? Ooh. Well, we know that it has 5 sides, and we know that the number of triangles in there is 3. This will all make sense in a little bit. So we have a definition, convex polygon, a polygon where each interior angle is less than 180 degrees. That is a convex polygon. You might want to draw this shape so that you know what it looks like. And then regular polygon, a polygon where all sides and interior angles are equal. So this is going to be the triangle, square, pentagon, hexagon, heptagon, octagon, nonagon, decagon, hendecagon, and dodecagon. So take a moment and think back to the sum of the interior angles for a triangle. Now compare that to what we found with the pentagon. Is there any relationship between the number of sides of a polygon and the sum of its interior angles? One way of doing this would be to use our knowledge of the sums of the interior angles of a triangle for other polygons by seeing how many triangles are needed to build them. For example, so we have a triangle, number of sides 3, number of triangles 1 equals 180. Quadrilateral, 4 sides, 2 triangles, 360. So let's just keep going with the pattern. So pentagon has 5 sides, and we found the number of triangles are 3. So let's copy this down. We could create a conjecture about the relationship between the sum of the interior angles S and the number of sides N. What could it be? The conjecture is S equals 180 times N subtract 2. So let's use an outdoor furniture and structures like gazebos. Sometimes use regular hexagons in their building plan. Determine the measure of each interior angle of a regular hexagon. So we know that a regular hexagon is going to have all the angles are equal. We know from earlier that the sum of the interior angles of a hexagon is 720. We can produce a conjecture that says S equals 180 and subtract 2. And we would be able to use this to determine the size of each interior angle simply by dividing by 6. So, if we go 180, 6 subtract 2, which equals 180 times 4, which equals 720, and we divide that by 6, that equals 120 degrees. So each interior angle of a regular hexagon is going to be 120. Of floor tiler designs custom floors using tilings in the shape of regular polygons. Can use the tiler use congruent regular octagons and congruent squares to tile the floor if they have the same side length. We know from earlier the sum of the interior angles of a square, a regular quadrilateral, will be 360. So 360 divided by 4 equals 90 degrees for each angle. Let's use S equals to find the interior angles of an octagon. So 180 times 6 equals 1080. So for each angle, this will be 135 because we're dividing by 8 because there's 8 sides. If two octagons are to fit together along one side, the two angles would add up to 135 plus 135, which equals 270. Think of a full rotation, this would leave a gap of 360 subtract 90, which is exactly 90, the size needed for a square. So, if you become a floor tiler or tile showers or do any home projects, this stuff is going to come in very handy for you. This means the tiler should be able to use a regular octagon and the squares when the side lengths of both polygons are the same, like we have in this picture. So the key points to remember: the sum of the interior angles of a convex polygon with n sides can be expressed as S equals 180 and subtract 2. The size of each interior angle in a regular polygon is 180 and subtract 2. And the sum of the interior angles of any convex polygon is 360. So let's try the example problem. Determine the measure of each interior angle of a regular nonagon. So nonagon means it has 9 sides. So my step 1 was a regular nonagon has 9 equal sides. My n equals 9. That's how many sides. And now I want to find the sum of the angles. So that would be sum equals 180 and subtract 2, which I found to be the sum to be 1,260. Then to find my interior angle, I'm going to take the sum and divide it by how many sides there are. So this will give me an interior angle of 140 degrees. Alright, so Rachel is tiling her bathroom floor. She is using regular hexagon and regular triangle tiles. The side length of a triangle tile is equal to the side length of the hexagon tile. Can she tile the floor without leaving any gaps between the tiles? Alright, so first let's start with our lovely hexagon, and it is regular. that total equals 360, so we would not leave any gaps in between. So your assignment is to do page 22 and 23 to 24. So this is a very short unit, so we have finishing off page 22 to 24, then there is a hand-in assignment for you, then we're going to do a review, and then there will be a test, and that is the end of the unit.